Good evening, everyone. My name is Aanchal, and we are all here to give a presentation on a capstone project named UV Concentrator. We are Team 48, and now my teammates will introduce themselves.
My name is Kunal Sharma and I am from EC branch.
My name is Udit Tyagi. My branch is Electronics and Communication and my roll number is 1018061114.
So my name is Rohan Gupta and my branch is ECE.
My name is Rajat Sharma and my branch is EC. I have written the electronics part in the project.
So now let's go through our presentation on this capstone project named UV Concentrator, and as all the team members have introduced themselves, so let's start with the introduction part. This project is mainly a fusion of robotics and science consisting of an integrated hardware and optics to collect the real-time data of UV and IR rays in a particular region. Now, our problem statement includes that due to the depletion of ozone layer, UVA and UVB rays are entering the Earth's environment, due to which many people are facing skin diseases and some are facing severe diseases like skin cancer. We introduce a solution that by making a 3D printed model, we will track the sun's path, and Arduino will be used to program this 3D model, and it will be fully autonomous. The main constraints that we faced in the making of this project are that the ozone layer fully blocks the UVC and UVB by 95%, or only UVA is allowed to pass, and we have to use the quartz glass lens for this because normal glass will block the UV rays. The methodology of this project includes basically three softwares, which are Tinkercad, Fusion 360, and Flash Print, which will be used to design the 3D model and will be used in designing, simulation, and printing of the model simultaneously. The components used in this project are Arduino, quartz lens, servo motors, LDRs, and aluminium ducting. So firstly, we have to capture the sunlight, and this will be done using a quartz lens, as the normal lens blocks the UV rays. And we will be using two servo motors which can rotate from 0 to 180 degree at a rate of about 0.3 seconds. Now we have to get the exact location of the sun. For that, we have to use 4 LDRs. These 4 LDRs will be placed in each quadrant of a circular disc, which will be located in such a position that they are isolated from each other. So this is basically the flowchart of our project. Firstly, the tracker will follow the sun's path, and the light will pass through the quartz lens, which will further make the UV and IR rays to pass through the aluminium ducting, and another lens concentrate the rays at a point, and the concentrated light is passed through the detector. So these are the softwares and tools that we used in our project. And now this is the 3D model of our project. In this model, we are using LDRs which are mounted on the top and rotate in the XY plane according to the data provided. The light falls on the lens above, then travels through the aluminium duct which is placed along it.
As you can see in front is the Arduino code which we have used to program our model. Hashtag includes servo.h is the servo library which we have used. Servo horizontal and servo vertical are the two servo motors which we have used in our model. Servo H and servo V are the initial values. Servo limit high and servo limit low are the highest and the lowest values to which our servo motors will go. We have used 4 analog pins A0, A1, A2 and A3 to get the data from our LDRs. And digital pin 9 and digital pin 10 are used to command our servo motors. Analog read command is used to retrieve data from the LDRs, that is left top, left down and right down. Then the serial print command is used so that we can see the data which is coming from the LDRs on the serial print monitor. Then we have used this formula. The D time is the difference time, TOL is the tolerance which we have in the LDRs. The AVT is the average value top, AVD is the average value down, AVL is the average value left, and AVR is the average value right. Now we have taken these 4 averages. Now we will have two differences, the difference vertical and the difference horizontal. Now we have used these if statements so that we can determine whether our servo motor will go up, down, left or right. Now accordingly we will give the right command to the servo vertical or to the servo horizontal, so that our servo can move accordingly. This is a circuit and the model. The light falls on the LDRs and interprets the data according to the code written in the as you saw earlier, and tells the servo motors to work accordingly in the right direction.
Coming on to the conclusion, this can be concluded in a very simple way, that this is used to detect the intensity of the UV rays at a particular location, which will help many dermatologists to develop more accurate products with respect to a particular place and the people living there. And it will be used in further scientific studies, and many researchers will have a great help with this project. So this was a whole presentation, and I would like to thank our mentors for helping us in such a smooth working of this project. Thank you.